we'll be reviewing an overview of precision farming with a very interesting title, 2020 Perception of Precision Agriculture. So we will also be discussing what has happened in the last 20 years. Dr. Harold Reed has been a privileged participant of the last 20 years in precision agriculture. As we mentioned in the previous webinar, Harold has organized the past InfoAg conferences and is very much related with the industry. And also we'll start thinking about what will happen in 20 years from now, which it's pretty obvious that we'll continue to see a lot of changes. So without further delay, I will pass the microphone and the screen to Harold and to get started with the presentation.
Okay, thank you, Ed, and welcome everybody. It's good to be back with you again. And I titled this presentation a 2020 Perception of Precision Agriculture. And I'd have to say that looking back, it's a lot easier to do it with 2020 vision than it is to look forward. Still a little bit cloudy on where we're headed on a lot of these things. When we look back 20 years, we think about what we had 20 years ago, what we didn't have that we have today, and what we dreamed about then. We have far surpassed what we thought we were going to do with precision technology. You think back 20 years ago, there was no such thing as a cell phone. There was no such thing as a laptop computer. Handheld computers, just on and on, details of things that we had to work with. GPS was just coming on the horizon about 15 years ago for agriculture use. It was being used in the military a little bit before that. So we've gained a lot. Things we thought we would do, we've done most of those, and we have gone far beyond that with the new tools and the technologies that we've developed, and our awareness of how to use those things. And we get new ideas every time a new piece of equipment's available. So I want to review some of those things, talk about what it means to us today, and do a little forward thinking to where we might be headed in the future and how we can position ourselves to do that. Put things in perspective, I look at precision farming as one of those tools that's going to help us to take care of the global population increase that's going on. This is a map that came in it's actually an advertisement, I think, that I got from National Geographic. It said the state of the earth in 2010. It just shows the density of global population. Actually, this map was from data from 2007, but the darker the red color, the more people there are, and you can see the South Asia, India is a huge population. Some of the islands in the southeast, there north of Australia, are also huge. Some areas of China, dense populations in parts of Africa, and a few in North and South America, but our American continents are definitely not as dense. We could almost reverse this and show where the food production is, our potential for food production in the U.S. and in South America. Obviously, there's a lot of potential in Africa, but that's going to take a while to develop that. Asia is really maxing out on their potential, as well as Europe. Not much opportunities for expanding there, and a large part of the continent of Australia is really not available for crop production. So kind of puts in perspective where we are. This next chart shows the arable land. Maybe that's a little better way to show this. You saw where the people are. Now we see where the land is that's available for crop production. The United States has the largest amount at 179 million acres. India, 169 million. China, 135 million. We get down to Brazil, 65. Argentina, 27. We look at France, we've got 19 million acres there, and so on. Just kind of give you an idea of where our potential areas are for crop production. far as yields are concerned, these three main crops for food production are wheat, maize, and paddy rice. Wheat has been pretty stable for the last 50 years. Corn and maize and paddy rice have increased at roughly the same general rate of increase. And still, at least maize is still going up. Rice seems to have leveled off in the last 10 years or so. And as far as the percent of the global harvest of each cereal that's attributed to each crop, again from 2007, you can see maize, wheat, and rice are about equal. Maize and rice at 22% each, and wheat at 31%. Barley, sorghum, millet come in at fairly big players as well. Kind of give, again, some perspective on the crops that we need to deal with. I'm biased toward corn, obviously, because that's where I've worked for my career and area that I'm most familiar with. So not going to hear much about rice and wheat in the rest of the presentation here. The technologies that we're talking about, though, could be applied in those crops in many cases as well. And some of them maybe even work better in those crops. We need to think about systems management if we're going to really move ahead and increase yields and increase productivity and build the basis for supplying the food, feed, fiber, and fuel that we're going to need to meet these demands. What we call the right management, putting the components together that interact when you make management decisions. And that system includes things like all of the component practices, the data that we collect, the information we have about the crop, and then the results of those decisions, the agronomic responses or yield that we get, the economic evaluation of it. Is it profitable? Are we going to be sustainable from an economic standpoint? And what are the environmental consequences of what we do? Those three things have to be considered really in every decision we make. As we move ahead with better technology, we get better data, and that allows us to make better decisions and allows us to make site-specific decisions. We don't have to depend any longer on average recommendations for a state, which 25 or 30 years ago, universities worked on making the best average recommendation for nitrogen for the state of Illinois or the state of Indiana, or the best average recommendation for maybe a part of the state, but they're certainly not referencing specific spots in the field. Now we have tools to work with, various kinds of sensors, guidance systems, monitors. We build on our historical records. We take samples, map those results of all these databases, use the maps then to control various operations. And we can do GIS analysis that helps us to interpret the information that we're gathering. Things like the Veris electronic or GPS-guided soil sampling, those are all important. GPS-guided tillage and planting operations. We're now putting the GPS guidance systems on the implement as well as the tractor, so that when we go on contour fields or on slopes, that the implement doesn't track perfectly behind the tractor, we can make adjustments so that the tractor moves over enough to pull the implement, and that the implement then is on the proper guidance within 1 or 2 centimeters of where we want it to be. But it doesn't have to all be done with electronics. We have, well, this one is electronics, but a soil sampling kit that you can use, put a sample of soil in, put some solution on it, and squeeze a drop of water or drop of the solution onto the sensor. It tells you what the potassium level or some other nutrient in that soil is. Or we can just use a chemically treated paper and with the right kinds of chemicals and a drop of sap from the plant, tell whether it's adequate or not in nitrogen or phosphorus or some other element. So these tools are available, have been in many cases for a long time. We need to put them together in that decision process. The Global Production Challenge has been issued by a number of people. Robert Fraley here, Dr. Fraley was speaking at the Farm Progress Show a couple of years ago. And he said that we needed to double grain production from 2007 to 2030 in order to meet the challenges. And so that's, he was talking here about how we might go about doing that. He's one of the researchers at Monsanto. Mike Edgerton, also from Monsanto, published in Plant Physiology a little more interpretation of that, showing the components of that yield increase. How much was attributable to agronomics, the lower part of the bars here. The next section was conventional plant breeding. You can see the bars that are increasing in size are marker-assisted breeding and biotechnology traits. And at least in the eyes of these researchers at Monsanto, that is where our potential yield increases are. I've got a little bit of question about that. I think they're being a little unfair, not providing enough credit to what we can do from an agronomic standpoint as well. So we'll see how that all happens. But I think if we're going to take advantage of all the benefits of the biotechnology traits and the new genetics that we're getting out of biotech, we need to improve our agronomic practices at the same rate, right along with them, because we're going to need to change plant populations and fertility, and maybe not only the amounts, but the ratios of different nutrients. I think secondary and micronutrients are going to be much more important as we look into the future to fine-tune our management system. And so there's a lot of questions to be answered. Fortunately, we have people that are working hard and addressing those. To graphically show this, for the last 43 years, we've had a record or a yield increase in corn in the U.S. Going at about 1.8 bushels per acre per year. It's been fairly steady. As we look forward, in order to meet that challenge by 2030, we have to increase that to 3% increase per year. And that's going to be a considerable challenge. We're going to have to greatly increase the rate at which we're increasing yield. It's going to take the best combination of science and agronomic management that we can put together. The global food production price crisis is really, or the global production crisis really needs to meet the needs for food, feed, fiber, and fuel. And we're going to be using our crops for all of those factors in order to sustain those populations that we're expecting to have. Precision agriculture can play a very significant role in that, as it can help refine those production systems. Through guidance systems, sensors, variable rates of inputs, and monitoring, those are all pieces of the puzzle of precision farming. And right along with that is the communications and data management. The internet has become a very important tool to agriculture as it is for all of society. Intranet, networks on the farm or even on the implements are becoming critical. Sensors on the toolbar that will send information back to the tractor and adjust its ground speed or adjust the fuel supply that's going to power the engine. These kinds of things are already built into the tractors and equipment that we're working with. And cell phones and PDAs. This picture here is about probably 15 years old now. It's the Apple Newton. That was really the first handheld PDA that was on the market. It's been obviously replaced by a number of other tools and cell phones that are so much more powerful than that one was. But we've come a long ways, and we're going to see even further advancements in that technology. And as we get more technology, we'll find ways to use that to help increase our management system in crop production. We need to take a look at all these various databases we have. We have soil survey data, We have information about the previous crop. We have information about the hybrid planted and different hybrids in a field. We can overlay those databases and draw some conclusions about the management factors and physical factors of the field. And we can maybe put a map together showing the fertilizer rate. If we're using variable rate fertilizer application, show the different areas of the field that had different amounts or maybe no amounts of fertilizer applied. And the yield map maybe comes into play in decision. It could be the previous year's map or an average of the last 5 years. Various ways we can take a look at that. We combine all of these together using various analytical tools, and we'll be talking about these a little bit later here with some demonstrations of some tools that might be available that you could use. Ultimately, the goal would be to produce a profit map and show which areas of that field are profitable, and if they're not profitable to farm, maybe this area up at the top of the field here that's very low in yield or low in profit, maybe we decide that that should be put into some conservation use and not even spend the resources to grow a crop in that area. But the goal then would be to either do a profit map of what we project the profits will be, or after the fact we can actually use what the actual profits for that field were. We'll switch over to a poll now, and you can answer this question. Remember how to do that.
I can launch it, Harold, if you wish.
And the question is, have you ever made a map of profit variability for one of your fields?
Okay.
Like we about got it.
So now we're showing the results now.
Okay. So 13% said yes, that you have drawn a map of profit variability. 87% said no. If we were all able to say yes, I was going to buy everybody a beer and stop the lecture, but I guess we'll have to. Okay, thank you for that information.